Hey guys, Stephen here from Heresy Academy. So this is where we left it off with our paddle and our bricks. We just laid them out like this. What we're going to cover in this video, which should be video 7, is we're now going to be able to move our paddle left and right using both the mouse, and we may put in the keyboard movements if that's how we feel. So before we do anything in terms of adding any scripts, I'm going to go up to your edit and go to your project settings here and click on input. You'll be met with this input manager in the inspector. So you want to open up your axes. First of all, I'm going to check the horizontal, check the name there. This is going to be important in the script because you need to reference the exact name. So for me, horizontal is still called horizontal, and mouse X is called mouse X. Okay. Sometimes I change the name of them, sometimes I don't, but you can create another one. Let's say you want to make your own. Click 19, click enter, then you can call this one new input, and then you'll decide which buttons are which. So just for reference now, the horizontal one, let's drag this out. So you don't have to give it any names or anything, but you can do if you want. So the negative button, the first negative button is the left button, which obviously, if you consider a graph, on the horizontal line, going this way is positive, so going towards the right, you'll go from 0 to 1, 2, and 3. Whereas left is a negative, which is going -1, -2, -3. And as you know, quite a few decent games will have A, W, S, and D as the controls. So A and D would be left and right here. So alternate negative, negative here. So we're going to stick with horizontal and then the mouse X here. These obviously don't have actual negative and positive buttons. You could put them in as well if you wanted to loop them all around, but we won't do that for this because that will mess up what we're trying to do. But down here with the type, you have mouse movement, key or mouse button, joystick axis. So this one obviously we'll keep as mouse movement, and then you can see all these different axes you've got for joysticks and the scroll wheel, and I'm using X and Y. Considering we're using the horizontal, so the paddle itself will only move left and right. We're only using horizontal, so we're only going to use X axes. So to get started, we're going to go down to our scripts folder. I'm just going to close these down. Yep. So open up your scripts folder where we've got our menu script. Right click and create a C# script. For this, I'm going to call it paddle. Now you can call it anything you want to call it. You don't need to reference the name of the script, it's just for you to know what it is. Straight away, I'm going to go over to the paddle when it's finished loading in. You see it's loading simple. There we go, go to the paddle. I think I'm showing you as well, you can drag in a script like that. If you want to get rid of any components or anything, you go to your settings here and you can reset. You don't want to reset this though. Remove the component, move it up, copy it, and then edit script here. So we'll edit the script. So now I want Mono Develop to open, which will probably take a few minutes because I forgot to open it before recording. Now we've got Mono Develop open, we're going to start obviously writing our script. We'll keep in the start function. Well, I'm not going to use it just yet. Just a quick explanation of what we're going to do next. We're going to move the paddle using the transform component, which would be this one, and we're going to focus on just the X, which is this. We won't focus on the Y, obviously that wouldn't do us any good, and if we start moving the mouse up, the paddle's going to move up and stuff like that. So we'll just stick to just the X, nothing to do with the Z, although I can probably make it disappear. No? Okay, we'll reset that back. Well, just Control Z everything, so it puts it back to what it was. Put that back to 0. Okay, so the way we're going to do it is, first off, we're going to start off with our mouse. We're going to add in 2 variables. One of them is going to be a boundary variable, which we'll more use in a few minutes. So we'll start off with public float, and we'll call this our velocity. So basically how quick our paddle will move in comparison to how quick our mouse moves. And then the next one, we'll call this one, so again it's a public float, we'll call this one bound X, because we're only going to put a boundary on the X position. We won't be using the Y position, so we don't need to put a boundary. And I'll show you how to set this up afterwards. Like I said, we're not going to use the start position, so we could take it out, but keep it in just for now. So to start off with, we want to actually grab our transform. So to do this, we're going to put it within a transform object, and we'll write transform and then call this a paddle, and this will be equals get component, and then within the more than less than signs, this will be the transform. So if I've not explained this already, when we get components, make sure you put these at the end as well. What it is, whatever we attach this script to, so we call it paddle, we're going to attach it to the paddle, or we've already attached it to the paddle. So automatically it's going to say get component of the paddle, and then it's going to get this component here. So this script is going to say get component transform, and stuff we do to it within the script will do these, we'll edit them in this component of this object. So if we attach this to the ball object, it will do the exact same thing, sort of thing. So we're going to now do another float, and we'll call this one mouse X. Sorry, let me just going to rename these. I don't know why I've done them with capital letters. I prefer to do them lowercase first. But yeah, so float with mouse X. We're just calling it mouse X because again, we're using the mouse and we're going to use the X axis. And then to get the axes or get the input from the mouse, it's very simple. We want to write input and dot get axes. So this is going to now get whichever axes we say. So if you remember, I said remember what it's called. So mine is called mouse X. So what this is saying, this float here will return a number depending on our horizontal mouse position. So here will be 0, this could be 1, this could be 2, etc, etc. So what we're going to do, now that we've got our input, we'll take our paddle and we'll find its position now. Paddle dot position. This is now when you put a dot and then something like a position or rotation, we're getting the information of this object here, which is this transform component that we call paddle. So what we're going to do, so by the way as well, this is in the update function, which as you can see, you should still get the same comment as me where it says update is called once per frame. So if you've got a computer that runs 60 frames per second, then you will see all this code will run 60 times in 1 second. So yeah, you get the paddle dot position. It is equal to its own position. Then you want to times that by velocity, which at the moment velocity will just be a standard 0. And then what you want to do is go times that by time dot delta time. And if you don't know what delta time is, as I just mentioned here, the frames per second. If you've got a computer that runs at 30 frames per second, then this is only going to happen 30 times in comparison to a 60 frames per second. So times it by delta time sort of gives it, I think delta time could be characterized as game time. So no matter what happens, no matter how many times this is called per frame or per second on your computer, it'll all happen now by this delta time component. I think yeah, you can. Oh, right, okay. So if you want to understand more information about anything, you can highlight it here, and go up to help bar, and click on the Unity API reference, or click Control and then click on it. That'll just give you a better explanation. As you'll probably find, I'm not very good at explaining things on the spot. So anyway, we've put our time at delta time, and then what we want to do is we'll make another float, and this will, again, it will return a number just like the mouse X. This time we'll call it paddle X, and this will now be equal to the paddle dot position dot x. Make sure it's just the x position. You don't want it to be equal to the z and the y. Otherwise, it will mess up your might mess up the numbers in this next line, which will be paddle x, and then this will be equals to, and it's called math f. It's just the it says here the public sealed structure math f, a collection of common math functions. It's something already provided by Unity and mono-develop, and it has things like what we've got now is clamp, and it's going to literally clamp. I'll write it out and then I'll explain it as we go. So after we write clamp, we want to now go paddle x, and then we've got to give it two values now. So as you can see here again, it says float value, minimum and maximum. So this is where our boundary comes in. So now we're going to write, so the minimum will be minus bound x, and then the maximum will just be bound x because it's already a positive number. So what this means is our paddle x position, which we've started out, the paddle x is here, which is equal to the paddle.position.x. So this could be, well, let's say this is at 0, okay? Our paddle's position is 0, and our boundary was -2 and +2. What it'll do, it'll quite literally clamp. It'll clamp this position, which is every frame is going to be changing to whatever the x position is, and it's going to clamp it within what we decide to say here. So if we say -2 and +2, which we only do once, we only put one value for it, which I'll show you in Unity will change. It'll make sure that no matter what input we do with mouse or key arrow keys, if we had a joystick, it would just move between these two positions and it wouldn't move any further. So yeah, that's why it's called clamp, because it quite literally clamps your position. And then finally, because what we've done is we've got all this information and we've given it a boundary, but we actually haven't told it to keep moving. So now, get our normal paddle, not paddle, whatever, and then get this dot position again. This is now going to be equal to a new vector 3, which is the way we plot our position. It will include an x and a y, but we don't want to do x and y. So what I write is our paddle x, and then you see it says here now float y. In a minute it will say float z as well. And then what we want to do for the y is paddle dot position dot y, because we're keeping the same position, and the exact same for the z. Yeah, dot z. Ooh. And that, ladies and gentlemen, should be how to do it. This is just for the mouse movement. Depending on the time of this video now, I may stop it and move on to the next one. Put the arrow keys into the next one, because we do want to change a bit of the code, but we'll do that shortly. We still want to set up the velocity and the bound x, but I'll show you how to do that as we move over. So we can always debug it and just build it and debug it, whichever it's called, and that'll basically tell you if you have got any errors, like if you're missing a semicolon or if your code is just completely wrong, which I'm pretty sure it looks alright. Yep, according to mono-develop it looks good as well. Okay, so when it debugs, we're going to go back to Unity. So now you've let it load in. Well, normally, but there we go. Alright, so what we'll do now is we'll make sure it's maximized on players off, save our scene, and we'll see straight away that it's not going to do anything. So what you want to do, for setting the boundaries, let's just say now it starts to go off about here, so that's 4.75. Okay, we'll put the boundaries, yeah, 4.75. I'm happy with that. What we'll do is we'll change the boundaries a little bit afterwards, because I do want to put a border into the game, and it works just the same, and we can set up collisions off that for the ball to bounce and stuff like that. For the velocity, let's just put 5 for now. Save it again so it keeps our figures. Okay guys, so one important thing to point out with the paddle dot position line here, I've actually made a mistake and I've left out a piece of information here. So we've got paddle.position, and then we want a plus, then open a pair of brackets, and then we'll end the brackets here at delta time, because that will be correct. And then what we want to do is a piece of information called vector3.right, and then times by velocity times by time dot delta time. I've actually got it written down in front of me, and I just completely overlooked it. So if you are running it in live time and you paused it to check and you, oh my god, it's not working, this is the reason why, because I completely forgot to plus the vector3.right. Otherwise, oh, sorry. And then again, I've just forgot, we still need to add in our mouse X here. Just looked at it, but oh my god, still missing it. Then do another one times mouse X there. And this now is correct. The vector3.right is obviously the right direction of your vector freeze, and then obviously the mouse X is the float here, which will be the number, the digit, figure, value that you get from your input mouse X, so you get a positive or a minus depending on where you're moving. Then the velocity is what we'll set in Unity, and time at delta time I explained earlier on. So let me save that, minimize it and run over to Unity. Ignore this error at the bottom there. And then, oh yeah, the boundary's fine, the velocity, let's check the velocity out. Okay, so as you see, the boundary works. I always look at the scene here for the game, and then put the scene there and the game there. I always look at the game for the scene. So we see here now, this is how quick it goes. Of course, increase the velocity. I mean, obviously, it just depends on how quick you can move the mouse, really, doesn't it? But yeah, that's how you do with the velocity. I'll put that back to 5 for now. I'm thinking that perhaps 7 will do better. Maybe not even 7. Yeah, we'll leave it with that for now. That'll be absolutely fine. And as you can see, the boundary works, and said we want to put in maybe an image here. Perhaps it could consist of making the camera a bit bigger just to include the image. So we keep the same layout sort of thing, but we'll figure that one out towards the next video. So this is how the progress is going, and we are going to put in the arrow movement in the next video. Do apologise for the little coding error before. I completely forgot to add in that bit and the mouse X. But yes, this will do for this video, so I hope you liked it. I hope you're still following along. If you need to, pause this video. You can see the entire code here. This will all completely work now. If you like the video, give it a thumbs up, and be sure to subscribe if you haven't already to see the new videos, like the one that's going to come out pretty soon, where we include our arrow keys, so the left and right, to move the paddle as well. Thank you.